everybody. My name is Jake. I'm from CoreOS. I'm a product manager. Before I get started, how many of you guys have heard of or used CoreOS? All right. And how many of you guys have heard of or used Docker containers? A little bit more. OK. And how many of you guys are familiar with the clusterization of the data center that's going on right now? They call it warehouse scale computing. OK, cool. Right. So what we are is we are a platform for platform builders. That means that we consider ourselves the undercloud to all of your infrastructure. What does the undercloud mean? The undercloud means we are a Linux server OS, just like Red Hat, Ubuntu, CentOS, any of the other things that you're deploying into your data center, but we're minimal and constantly updated. We aim to be the undercloud by providing just enough operating system to get your containers running, to follow the containerization movement, but a small enough operating system that we can effectively secure it. So how many people here were affected by Heartbleed? And shell shock? I'm probably the same people, right? OK, so right. One of the problems that people are experiencing right now is they have these super old versions of RHEL and Ubuntu that they're running in their data center. Sometimes these are still supported, sometimes they're not. And sometimes when one of these exploits come out, it's easily patched and updated, and sometimes you're stuck on an old version, so it's not. So we liken our operating system to the way the browser vendors originally started working. Back in the old days, the dark ages of the browser vendor, the browser wars, we had Firefox and Internet Explorer that were updated manually, which means that when the browser vendor released a new update, they expected their users to go to the website and download the new numbered version and install it on all of their desktops. This was horrible. We ended up with things like Internet Explorer 4 holding the entire internet back. We ended up with horrible security exploits that really the browser vendors had no way of patching or controlling. Along came Chrome. Chrome changed the game. They said, you know what, forget it. We're going to automatically download and apply patches, and as soon as the user restarts their browser for any reason, they're going to be running the latest version of Chrome. This changed the game. So from then on, Chrome was secure. Not to be outdone, the other browser vendors said, wait a minute, this security thing is cool, let's do that too. Once all of the browser vendors were delivering these automatic updates, we were set free from the old versions of browsers holding back the internet. And from that, we got amazing things like HTML5. They were able to be delivered as browser-specific vendored prefixes, and then they eventually became standard across the board. CoreOS is that same model, but applied to the operating system that runs on all the machines in your data center. So we speak the same protocol as Google Chrome, which is the Omaha protocol, and we will automatically download and apply updates to your server. By default, we do it without even asking you. Is that scary for anybody? Are you guys OK with us rebooting your servers whenever we feel like it? No. So that's where the whole clustering movement comes in. So we ship a base Linux userland. We ship it read-only by default to keep it as stable as possible. And then we ship a few tools that help you set up this operating system and cluster them together to create a cohesive application cluster. This is kind of a short presentation, so I'm going to skip some of these. But one really important one to note is that we actually ship Docker with our distribution. So as I mentioned before, we are an operating system that serves primarily to be as secure and small as possible, but to get you running your containers as quickly as possible. So back in the old days, when people would ship an operating system, they would ship a specific version of the kernel. They would ship a specific version of all of the application runtimes, such as Python, Java, Nginx. And very importantly, they would ship a specific version of the libraries that get compiled into your applications. OpenSSL, for example, which was the one that affected you all with the Heartbleed exploit. In the new version of the world, CoreOS moves the line to the left. We say put all of that stuff inside your container and bundle it with your application. This allows us to have a very minimal operating system, but also to allow you to run different versions of different dependencies and to bundle only the runtime that each specific application needs with the binary that you're shipping for that application. This leads to really interesting things like you can have 2 different versions of Java on the same server, and it doesn't have to be a horrible headache to move from Java 1.5 to 1.6 or 1.6 to 1.7. So that's where CoreOS steps in. We ship just the part to get your containers running, and then your containers do the rest of the work. I know what you're saying. We can't have you rebooting our servers all the time because it'll impact our customers. For this reason, whenever you run with CoreOS, you have to run with an N+2 distribution. This means that however many servers it takes to effectively deliver your service, you have to run with a margin of at least 2 extra. Why 2? 1, because we can reboot one of your servers at any time, and 1, because you don't want a single failure to take your service down while we're rebooting one of your servers. So the other thing that you might be thinking is, well, if I'm taking all of these dependencies out of my application and putting them into or out of my operating system and putting them into the containers, doesn't that also move all the vulnerabilities into the containers? And the answer is that yes, it can. So the other thing that we do is we provide a way to automatically update your container, including all of the dependencies, whenever you make a change to your code, and coming soon, whenever any of the vendors makes a change to any of the versions of the software that's getting installed in your containers. I joined CoreOS as part of an acquisition of a company called Quay.io. What Quay.io is a place for you to store your container images. So you can think of us as the GitHub for these application bundles. And with that said, I guess I'll go to a quick demo. We're a Linux operating system, so my demo isn't very flashy, but I'll do my best. So this is an application, one of the dashboards that we've built called Core Update, and this keeps track of all the different Linux servers running different versions of CoreOS within your cluster. Of course, this is the demo version. They wouldn't let me show production, but I set up a New York Enterprise Tech Meetup cluster just for today. So what I have is there's actually 20 instances that are all running version 376.0 of CoreOS. We number our versions based on the number of days since our first stable release. So this one was released 376 days after our first release. The current versions are in the 450 range. But what I'm going to do, this is a burn down chart down here of all the different versions of all the different servers within your data center. I am going to update these instances to a new version of CoreOS. So instead of tracking the QA channel, we're going to track stable. And then I'm going to unpause updates. I said I'm going to unpause updates. Great. So we set a policy for this particular channel to have it update 5 instances every minute. So it should go pretty quick. And as you can see, some of them have already started updating. So as the update is rolled out to the different instances, this chart will show the burn down. I'll come back to that in a second because it's not very exciting to watch servers update themselves. The other service that we mentioned was Quay.io. So this is the GitHub for your Linux container images. In order to give the best user experience, we followed the GitHub paradigm very closely. So the UI may look very familiar to some of you. These are our actual images that we run in production. So this is the Quay container image that we actually run for Quay. So we eat all of our own dog food. This is running on CoreOS, and we deploy from our own container image repository. So if we just poke into one of these images, this is probably one of the largest images on Quay. We have hundreds of releases, but you can just get a sense of the kind of UI and the kind of introspective ability we give you to look into each individual image. We also keep track of whenever you make an update to your container, we keep track of what files changed. This is very important from a traceability perspective, especially if you're working in the enterprise, which all of you are, hopefully. And then we also have these usage logs, which are another feature that are very important to enterprise. So anytime anybody in your organization changes one of the images that you're storing on Quay.io, we keep track of it. We log who the user was that made the action, how they made it, how they mutated the data. These are some of those builds from GitHub that I mentioned earlier. So this is an application getting automatically updated when a developer checks in some code. So we get great auditability to see who changed what. Again, we can see which users are part of our organization and which team they belong to. This is great for making sure that people only have the right permissions for what they need. And here's an example of a repository that's attached to GitHub. So what this build trigger means is that every time the developer pushes to GitHub, the container image will be rebuilt. All of the apps that CoreOS builds are single-page apps that are built on top of robust APIs. For most of them, we publish the API. So this is the Quay API and an Explorer to let you play with it right here live. We believe that this is the way to build apps in Web 2 or 3 or 5 or whatever we're on nowadays. And that lets you build the kind of tools that you might need in your enterprise to manage your infrastructure and manage your container images that comprise all of the apps deployed across your data center. Let's go check back in with our update. Fantastic. We're about 60% of the way done. And as time goes on, the rest of the servers will update themselves, and we'll be running the stable version of CoreOS. And I missed it at the beginning. I was supposed to talk about where we are as a company. We are a Series A company. We've raised $8 million to date, and we're funded by Kleiner Perkins, Sequoia, and Andreessen. Okay. Any questions? No, we're really cool. We're really secure. So we're mostly based out of San Francisco. We have a small team here in New York. We work out of Workbench with John and Cameron. I highly recommend it. It's a fantastic workspace. And we're hiring as quickly as possible. So if anybody is a Linux nerd or knows any Linux nerds, please let me know, and we'll work with you. So, question?
Talk about a couple of use cases or customers.
Okay, sure. So we're pretty early stage. A lot of our customers aren't mentionable right now, but Sony PlayStation is using us for some of their internal development workspace work. There was a talk, CoreOS and PlayStation. You can find it online if you look for it. If you've ever heard of Deis, they're a platform as a service built on top of Docker.
They demoed last month.
They demoed, right. So Deis is built on top of CoreOS. Rackspace is using CoreOS. I'm not sure how publicly they've gone with what exactly they're using it for, but we do have large enterprises using us for very real workloads. In addition, everything that we do is also built on CoreOS, obviously, and we love the model.
Does it matter whether your servers are using VMware or any other different virtualization software? Or they're the dominant one? I'm just curious, does it make a difference?
Okay, great question. So the question was, does it matter if you're using VMware in your data center? And I guess the answer to that is how you're using VMware. If you're using VMware as an application deployment model, this is sort of a competitor to that. You can think of Docker and CoreOS, where CoreOS is the hypervisor, like your ESX, and Docker is the individual application. We will fully work within VMware, so you can boot a CoreOS instance in VMware. You just lose a little bit of the power of having CoreOS run directly on your public cloud or on your bare metal. And I failed to mention that we do run on all of the public cloud providers, or at least all the major ones, and we also run on bare metal exactly the same. So our operating system is shipped as a single binary that's cryptographically signed, so we run the exact same code, whether it's on bare metal or in any of the clouds or under VMware.
So do you typically get deployed in a greenfield operation first? Greenfield segment of the data center or a new data center?
the question is, do we typically get deployed in a greenfield section of the data center? And I think that would probably be fair to say at this time. This is a massive shift in the way companies traditionally deploy applications. So you're not going to deploy onto RHEL one day and then the very next day deploy to CoreOS. So most people who are moving to Docker containers or to a microservice architecture, they find that that's a good position to try and use CoreOS and see how it works for that new development with the microservices or Docker. Anybody else?
Unrelated, can you talk about why you're hiring in New York? You got a strong pedigree of Silicon Valley-based VCs. I'm just curious why you built a presence here.
Because I'm too stubborn to move. No, so Quay.io, the company that I was a founder of, and that CoreOS acquired, is founded out here, and part of the terms were that we get to stay here. So we love New York.
Yeah. So what are a couple of the big challenges to more, I would say, broader, large enterprise adoption of CoreOS and Docker?
I would say that it's the big challenges are, number one, getting your operations team to sign off on it. It's a very new beast. The model makes sense, right? Like, we can all agree that the internet is better now that all of the browser vendors are automatically updating than it was back when IE4 ruled the world. So getting the ops people to sign off on it and say, we are stable, we're production ready. Ops people don't always believe it when a company says that. So getting them to buy in, getting your developers up to speed with Docker and deploying everything in containers. Other than that, it's pretty, because we're CoreOS developers, we literally moved off of Ubuntu and onto CoreOS in about 5 hours. So it was not a painful move for us, but we were already packaging everything in containers to begin with.
How do you verify that the upgraded CoreOS will correctly work with the containers that we already have?
That's a fantastic question. The question is, how can you verify that an update that you're pushing will work with the containers that you already have? And this is basically through the magic of the Linux userland. So Linux has made a promise to the world that it will never break userland. So it will never break the system calls that you rely on, and it will never break just the way the operating system works in general. Everything that they add to Linux is done in a backward compatible fashion. When you build and deploy everything in containers, the only thing that's shared between the different containers is the Linux kernel itself. In addition, the minimal operating system that we do ship, which are those tools that I briefly showed, that's all mounted in a read-only operating system, so not even root can go in and mess with those fundamentals of the operating system. So all of that stuff is controlled by us, and only a very minimal operating system surface area is being exposed into the containers. Does that make sense? Oh, we can talk during the break.
What is the security risk of doing this? In other words, you're doing basically an in-service upgrade of the servers. Have you thought about the vulnerabilities that might create in terms of security attacks on servers, application delivery controllers, etc., that could be impacted by this upgrade taking place?
Okay, so the question was, what are the security impacts of having an upgrade model like what we're promoting? Basically, the only security vulnerability or the only attack vector through having this auto upgrade model would be getting your servers to trust an update server that wasn't our own. And that's the reason why the update service that we ship with the operating system uses keys that we publish to cryptographically verify that the image that you've downloaded is exactly the one that we've created. We sign a hash, so we verify both that the contents haven't been tampered with and that we're the ones who originally created the server OS. Other than that, the OS has an actually smaller attack vector than any of the other servers you might normally ship into production, because literally the only thing it has is a Linux kernel and the minimal tools that we have to ship to run your containers.
So if Can you talk about which one of your customers did get attacked or not, or how smooth was the transition to download the patches for Heartbleed or the OpenSSL?
Okay, so the question was which of our customers got attacked by Heartbleed, and how smooth was the transition to patch it? None of our customers told us that they were attacked by OpenSSL, so presumably some of them were affected and some of them were not. In terms of how easy was it to patch, for example, for the Quay.io container, we just rebuilt it with a newer version of OpenSSL, and we pushed it out to all of our CoreOS servers. So that was...
And no interruption of service, the application was running fine, so...
Correct, but that's because of the way the app is architected. So this goes back to the N+2 architecture, where you have to run at least 2 extra nodes in order to be able to roll out these updates to your running fleet. So there is you have to do some work to make sure that your app is cluster aware and that it can run in this fashion. So for example, you wouldn't want to deploy a single production database onto one of the CoreOS machines because it's pretty hard to bring down your database all the time. So, and for those use cases, you have to use one of like a clustered database solution, or you have to give your database code out to it. Like you have to use a database vendor, for example.
To follow on this question, if the security breach needs to be patched in the container, let's say you have 20 or 100 containers, then you ought to do this work 20 or 100 times and redeploy them. Conversely, if you go with the traditional model, launch a new VM and upload your app to it.
Mm-hmm. So there wasn't a question, but I think he was pointing out that by moving a lot of the libraries into the application containers, you now have to update your containers if the vulnerability exists within the realm of the container. And that's absolutely true, and that's why we're trying to create tools and create services that help you rebuild and redeploy your containers automatically. So for example, if we had the service available that could talk to Canonical's upstream servers and it was aware of whenever a patch came, then we could automatically rebuild your container, and then we could hook your container up to something like Core Update, and we could roll that update out across your fleet as well. So these are all the things that we're thinking about, and these are all the things that we're working on. It's not there yet in terms of the container deployment.
Time for one more.
Yeah, I think I'm pretty much out of time. Is there one more? All right, awesome. Thanks, guys.